In section 5.4, you will learn about the mean and the standard deviation of the sampling distribution and sample means, and about the central limit theorem. Let's start with the sampling distribution of the sample means, which we abbreviate SDSM. So, if we take numerous samples of size n from a population with a mean of mu and a standard deviation of sigma, then the mean of this new distribution that you've created from all the sample means is mu. In other words, the mean of the sampling distribution is the same as the mean of the population. And the standard deviation gets much, much smaller, assuming you take a reasonably sized sample size n, and it becomes sigma, the population's standard deviation, divided by the square root of the sample size. Now, the central limit theorem. If you take samples of size n, as long as n is greater than or equal to 30, and you take them from any population with a mean of mu and a standard deviation of sigma, then the SDSM approximates a normal distribution, and that's any population, uniform, skewed, bimodal, any of those. The sampling distribution of sample means approximates a normal distribution, and the greater the sample size, the better the approximation. If you start with a normal distribution for your population, then the sampling distribution sample means is normal for any sample size n. In either case, again, the mean is the mean is the mean. The mean of the sampling distribution of sample means equals the population mean. The sampling distribution of sample means has standard deviation equal to that population standard deviation divided by the square root of n. So sigma sub x bar, the standard deviation of the sample means, is equal to sigma divided by the square root of n. This standard deviation is also called the standard error. So here's graphic picture. Here's a picture, hopefully, that will show you what happens. So we start out with this bimodal, bumpy-looking distribution with a standard deviation of sigma and a mean of mu. And we take a whole bunch of samples, each of size 30 or larger, and we make a new distribution of all the means of all those samples, say 100 different samples. Each sample is n is greater or equal to 30. And we find all those sample means, and we get a new distribution because every single sample is going to have a slightly different mean. And we end up with approximately a normal distribution with a mean that is the same as the population mean, but a smaller standard deviation. Standard deviation of the population divided by the square root of your sample size. Not how many samples you took, but what was the sample size of each sample. On the other hand, if you start with a normal distribution, you end up with a normal distribution, just a skinnier bell-shaped curve. And that's the basics of the central limit theorem.